So hello everyone, hope you're doing well and welcome back to my channel. Today we are at day 8 of the June daily Leetcode challenge and we are again having a easy question in front of us. Let us see what the question is. It's question 1351. Count negative number in a sorted matrix. So yeah, before going to the question, let me give you something brief about it. Okay. It's going to be a very very simple question. You just need to understand how to traverse in a 2D matrix. If you are able to do that, you can solve this question. But this reminds me of one thing, that this kind of questions, are like a layer. Okay, there will be one layer, then you have to uncover the second layer because you have to explain the first layer, something like that. Okay, so what the hint here is, after solving it using the brute force approach, which will get accepted, obviously that is fine, you will have to think of how to optimize it. Okay, what could be the better way and how to optimize further. So these kind of questions you can definitely expect in an interview. Okay, this is on the easier side, but somewhat tougher than this you can get in the interview. You will have to code the brute force approach first, and then and so on, and like ultimately you should be able to reach a optimized approach, which should be better in terms of time complexity and space complexity compared to the brute force approach. Okay, so now coming to the given question, what we are given is, as I mentioned, it's a matrix. It's not a square matrix. Okay, M and N don't do same. Okay, it's called grid, as you can see in the input. So what special about it is that it's a non-increasing order. Okay, I will discuss about this in detail, what is meaning of this, but let us see the whole question first. Okay, so they are saying that it's a non-increasing along both row-wise and column-wise. Okay, it's both row-wise and column-wise, non-increasing. Return number of negative numbers in grid. Okay, so it's something very simple. Okay, what we have to do is, you can use a simple traversal. Okay, you can use two for loops. Okay, for you can use two for loops. One for loop for going in the for each row, and another for loop for going number of elements in that row. Okay, you can use two for loops and just count the number of negative numbers, and your answer will get accepted. Okay, for example, in this particular example, this is the first negative number, this is the second negative number. Okay, third and fourth, fifth, sixth, seventh, and eighth. So answer is eight. Okay, as simple as that. This is going to be a very very simple approach. Uh, you just need to understand how to iterate over each element of a 2D matrix. Okay, so this is what will be tested in the brute force approach, and I'm sure the answer will get accepted because the time complexity will be over m into n, and the space complexity will be over 1. Okay, so yeah, that was it. But see, the ultimate aim here is to think of something better. Okay, this much anyone can do. Anyone who is like just 1 week old in programming, they also can do this. But let us now come to something which will be more serious. Okay, so now how to optimize it further. Now see, we have to understand the definition of these things. Once we are done, then we will be able to think better. Okay, so what is non-decreasing? Something which is decreasing, right? Sorry, what is non-increasing? Non-increasing means something which is decreasing. That is fine. But why they have mentioned non-increasing? Just try to understand. See, 1, 2, and 3, if I talk about, they are increasing. Okay. If I talk about 3 to 1, then it's decreasing. That's fine. But what is non-increasing? So the idea here is, see, they have mentioned row wise and column wise, it's not increasing. So just see the examples here. 4, 3, 2, and 1. So it's basically decreasing. That's what they're trying to refer to non-increasing. But remember one thing. Uh, they can be same. Okay, what the idea here is, see, after 4 you can have another 4. Okay, 4 4, then maybe 2 comma minus 1, something like that. Okay, 4 comma 4 comma 2 comma minus 1. So idea here is, they can be same. Two consecutive numbers can be the same. That is the basic idea behind what is non increasing. Okay, non increasing means they won't increase, but they can be the same. Okay, they can decrease, they can be the same, but they will never increase. That is, any two consecutive numbers, will can be the same. They can decrease. That is, if you talk about index I, it will be somewhat higher compared to index I minus 1. Okay, as you can see, a 4 is slightly higher than 3. Okay, but they can be the same also. But there will never be a case where the index I is smaller than the index I plus 1. Okay, please note this point very very clearly. This is the whole conclusion of what I've said till now. Index I can never be smaller than index I plus 1. It can be equal to index I plus 1, or it can be greater than index I plus 1, but it can be never be smaller than index I plus 1. Okay, so that is the basic idea of what is non-decreasing. So you will realize that in the brute force approach, which I just mentioned, using two for loops and all, you are not using this fact. Okay, we are not using this fact. So what we can do is, see, just try to understand. As you can see here, this thing, if you talk about, okay, it's just like a sorted array in a reverse order. Okay, just like a sorted array in a reverse order. Okay, so what we can do is, you can use a binary search in along these objects. Okay, for example, see, ultimately what I have to get the number of negative numbers. So like break this question into each rows. So along each row I need to get a how many negative numbers are there. So what we can do is I should try to find a number which is the which is the borderline. That means, for example, this two. After this two, all numbers are negative. Okay, if I get such a number, I can easily get the count of the number of negative numbers around that row. Okay, for example, come to this. Okay, this one. If I get the index of this, okay, and if I get to know that this is the only after this all numbers are negative, what I can do is I can use some subtraction. That is, I can subtract. For example, the length is m. I can subtract m minus this number, okay, the index of this number, to get how many negative numbers there after that. Okay, that can be done. So how to find this thing now, how to find this particular number now, that can be done using a binary search. Why binary search? Because we analyze that each row is basically sorted. Okay, each row is basically sorted in reverse order, so that fact can be used to do a binary search. So you can do that if you do a binary search, and if you follow this kind of conventions, for example, each row I am taking it as m. Okay, so the basically the time will be that will be required for each row will be log m time. Okay, log m, and we are going to do that for n rows. Okay, n rows. So the total time constant will be n into log m. Okay, and the space complexity will be remaining same. It's over one. That is also a good approach, but uh, see, binary search and all. See, if you can implement it on your own, from scratch, that is fine. But if you're using inbuilt function, again, that is not something I will be happy with. Now we have to think of a solution which will be really see, again, in a binary search you will get to know that we are not using a fact. That, see, row wise we are using this fact, but column wise we are not using this fact. This is something I don't want to miss, because it's given in the question. Okay, so how to use this fact as well. So the current solution which I have coded will be using that fact as well. Let us see how it works. See, n refers to the number of rows. Okay, similarly m refers to the number of columns. Please be very see, if you don't understand these things, the code will be tougher for you to understand. Okay, please just remember that m refers to length of each row. Okay, length of each row refers to m, that is the number of columns. Okay, so this will be the final count which will be written as the answer. It will count the number of negative numbers. Okay, so see, here I'm going to use this particular variable. Only this variable I will be using. Okay, only these two variables basically. Only these two count. And the so what it see is first. Let us see what it means. First positive number index. Okay, so as I told you that approach. See, I have to find only the first positive number. After that, all numbers should be negative. Once I get the index of that number, I can get basically the number of negative numbers in that whole row. Okay, so that the index of that particular number will be stored in this particular variable. I'm initially making it as m minus one. Okay, that is the last value. Okay, last value. I'm starting with that initially. Okay, this is the index of the first positive number in that row. Okay, now I will be going through each of the rows. Okay, I will be going through each of the rows. Please pay attention what is being happening here. I will be running this while loop till my this particular index is greater than or equal to 0. That is, once it reaches minus 1, I will stop that. Okay, next I will be checking if the index. So for initially it is referring to m minus 1, right? Initially referring to m minus 1. I will be just checking if that particular element in that particular index, okay, if it is less than or less than 0. Okay, I will be just checking if it is negative. Okay, if it is negative, I will subtract it by minus 1. So why we are doing like that? See, because for example, if I talk about this row, I'm starting with this row, suppose. So the first element is negative. Okay, so because this is negative, so maybe, see, because I told this index refers to the first positive number. Okay, not negative number. So I will be just moving it one time left. Okay, 1 unit left of it. Then analyzing if this is the one. So till I come to this one. Okay, because this one is the first positive integer after the all are negative. So till I come to this one, this loop will be running. Okay, this while loop will be running. Okay, but remember there are two stopping conditions here. First is if I get the first positive element. Okay, then I will stop. Next is if I do not get any element, any positive element in the whole row. Okay, then also I will stop. Okay, that is the basic idea here. So this loop will turn until line. Okay, so when this loop ends, basically there will be only two things happening. First thing is that I would have reached the index minus 1. Okay, that is the whole row is negative. Next thing is next condition, that next thing that would happen is I would have reached the index where that is the bottom one, that is all index after that are having negative values. Okay, next, I will do the count calculation. How I'm doing the count calculation? See, it's very, very simple. See, I am at a positive index. Okay, so what I will do is the last index, that is the m minus 1 the index minus the this index. Okay, so this is the last index m minus 1. Okay, minus the current index of the first positive number. Okay, this will give me the total negative numbers in that particular row. Okay, remember I'm doing this for each row. Okay. Okay. So here, see, first thing is we utilize this factor, okay, row wise factor, okay, because once I reach the first positive number, I did not traverse further, okay. So I use this factor also row wise. Now coming to column wise, how it is helping me. Remember, this particular variable is declared outside the loop, okay. It's declared outside the loop, and it is once it is made minus. For example, once the value comes -1, okay, it will not be changing, okay. There will be no way. See, this particular thing is outside the loop, so it's not getting declared inside the loop, okay. So what will happen is, yeah, so it will be once it becomes -1. See, the idea here is, see, once you get a negative element in the first index, all the elements below that are going to be negative only. That is the basic idea, right? So that's what we're using here. Once we get that from, we will do checking if it's a negative number or not. If it's a negative number, we won't be changing it further, okay. So it's a positive number, we won't be changing it further. So the basic idea is, with this code we are using both the row wise and the column wise list, okay. And finally, this is how we are calculating, just math, simple maths we are doing and getting the number instead of traversing through every element, and finally updating the count. Now comes the tricky part, how to find stand complexity. Many of you will be thinking that it's going to be, see, for each row I'm doing some calculations, right? And this will be, if you see, m is the length of the row, so we'll say n into m, but remember that is not the case, okay. So it is going to be m plus ny. See, for each row we are going and rows are n. So n is fine. Why this n is coming, we all know. But how m? Okay, remember one thing. We are traversing from m-1, that is here m-1, till m is greater than, so till m becomes -1. Okay, so only that part we are traversing. We are not calculating again and again. Okay, once it reaches -1, it won't change. So that till then only it can decrease. So it can only decrease. Remember, it cannot increase. So the idea here is, till m times only we will be calculating this. Okay, so the loop will be running till m times only throughout. For all rows combined, it will be running for m times only. So that's why the time complexity of m plus n. If we talk about space complexity, this is the only calculation which we are doing. We are not using an area or anything, so space complexity will be often. So yeah, from there, so basic idea, this is one of the solution we know which uses both of these facts. See, I will definitely request you to understand this. Just go through the example once, because I've been a bit faster and I've not explained too much. Because see, if this is 4, this will be decreasing. That's fine. But remember, three is also decreasing, okay. So along column is also decreasing, so 4, so here 3 and here 1, okay. So that idea is also important, okay. Along we go down the row, that is along the column, if we go down, the values will also decrease, and that is the idea which we are using here, okay. Once we know that a negative number has been reached, we need not calculate it further, okay. We need not traverse the indexes below that. So for that, we just do a simple calculation, and that's it, okay. So yeah, fun, that was all for today. uh, if you have a better solution, please do comment below. And if you have any doubts, we can discuss it further. That's all for today. See you tomorrow. Thanks a lot.